want to take a look at writing equations from context, okay? So whether they're linear, quadratic, or exponential. But before we do that, we're just going to quickly remind you what the shapes look like. So if it is a straight line, whether it's going up or it's going down, this is a linear function. If it looks like the alphabet letter U or an N, it is a quadratic function. If it looks like a slide, see sliding, or a roller coaster like that, going up, oh, it's flipped. Okay, so it has an isotope, which is this perfectly straight line. That is exponential. So that is from a graph, exponential. Now I'm just going to quickly recap all of it. What does that mean? Okay, so let's just quickly look at each one. What is the equation for a linear function? Well, that's going to be y equals mx plus b. All right, let's look at what each thing means. What does m mean? So m is the slope, okay? That's how it's changing, okay? A constant rate of change. And then b is your y-intercept or your initial, right? So your start, your y-intercept, or your initial. It usually happens where x is equal to 0 if you're looking at a table. What is a quadratic? A quadratic is, and there are three forms, but we're only going to focus on standard form. So we're going to do the one that says y equals ax squared plus bx plus c. And the only thing I'm going to remind you of this one is that the c, just the plus c by itself, is your y-intercept, where it crosses the y-axis. All right, looking at the exponential function, you're going to have y equals ab raised to the power of x, and reminding you what each of those things is. A plus c, so a plus c, if there's nothing there, it's 0, so there's usually nothing, that's why a is it. But a plus c is equal to your y-intercept, your start, your initial, okay? Then your b is your growth, if it's bigger than 1, or your decay, if it's between 0 and 1, not if it's negative. If it's between 0 and 1, that's like 1/2. Whereas growth is like 5/4. Okay, so bigger than 1 growth, between 0 and 1, not negative, 1/2. All right, and then C, if you have a C, that is called your isotope. All right, your isotope, and it's always a line, so it's y equals some number, okay, which is obviously C. All right, so that's a quick refresher of what the equations are, what they look like, so you can identify them from an equation. Doing them from a contextual problem, what you're looking for is, if you have a linear problem, you're looking for something that has some kind of initial start and some slope that's the same each time, that's constant. All right, so we're saying starts somewhere and has a constant rate of change, and has a constant rate of change. And we're going to look at some examples in just a second. All right, again, what that means is, from the previous video, you're adding or subtracting the same number each time. All right, so we're going to look at some contextual word problems that do that. For quadratic, okay, if you just look at the shape of quadratic, it's something that goes up and comes down. So anything with a ball, if I kick a ball, so anything with a ball going up, going down, a rocket, some kind of dolphin, a fish jumping up and down, you know, anything that's going up and then comes down. Also, if we remember from the quadratic unit, anything with maximize or minimize revenue. So this will be a maximum profit, this will be a minimal loss, something like that. And then also, one last thing, area. So when you have the length is 5 times the width, something like that, for what the area is this. So those are the 3 situations where you'll find that it's quadratic. All right, then finally, for exponential, now we just did this unit, so it should be really fresh in your mind, but I'm still going to remind you. anything that grows exponentially, like it starts off real small, then it boom, really goes, or it decays. So you're looking for anything that grows / decays exponentially. Okay, so what that means is half, double, triple, quadruple, and I'm not writing all these words. Quadruple, anything with a percent, so like it's increasing by like 10%, and it doesn't say simple interest. So if it doesn't say simple interest, anything that's like decreasing by, I don't know, 12.8%. Again, anything with percent really in it, because remember, we do the percent divided by 100, then you're going to do 1 plus for growth or 1 minus for decay. So anything like that, just make sure that it's not simple interest, because if it says it's simple interest, then it becomes linear. All right, so now that I've gone over what it looks like as a picture, what it looks like as an equation, what you're looking for in context, you are now going to do this to check your understanding. Get 3 different color highlighter / color pencils and color and highlight all your linear functions, including linear, the same color. All quadratic functions, including quadratic, the same color. And all exponential functions, including exponential, the same color. So what do I mean by this? I mean, if you pick yellow for linear function, anything that's linear here, you're going to color it in yellow. If I pick blue for quadratic functions, anything in here that's quadratic, you're going to color blue. If I put green for exponential functions, anything that's in here that's exponential, you're going to color green. So I'm going to randomly pick a couple. Let me pick this one, a ball. Oh my gosh, I read no more. It's thrown upward. That means it's going to go up and then it's going to come down. What does that look like? That is quadratic. So I'm just going to color just a little bit blue. All right, let me pick another random one. You start saving $100 every month. All right, let's think about that. First time of the month, I save $100. The next month, so this is month 1. Month 2, I save another $100. Month 3, I save $100. And I keep saving $100. All right, how is this changing? It is a constant rate of change. Therefore, that means it's linear, which is going to be yellow. Now, for some of these, what you might have to do is also write the equation. So let me write the equation for this. So I come back up here and I look, okay, linear, y equals mx plus b. B is my slope, my constant change, and my start is my y-intercept. All right, cool. So write my equation. All right, so y is equal to my constant change, which is $100 every month. All right, and what did I start with? Nothing. And that's it. Okay, so I want you to do that for each of these problems, and then you're going to answer everything on this question. Let's practice.